Hi friends, welcome again to new video in my YouTube channel, HRB Embedded and Craft. In this video we will be learn to interface Max30100 pulse oximeter sensor with Arduino Nano and display oxygen levels in the blood and pulse rate through LCD display. A pulse oximeter measures your blood oxygen levels and pulse. A low level of oxygen saturation may occur if you have certain health conditions. Your skin tone may also affect your reading. Pulse oximetry is a non-invasive test that measures the oxygen saturation level of your blood. It can rapidly detect even small changes in oxygen levels. These levels show how efficiently blood is carrying oxygen to the extremities furthest from your heart, including your arms and legs. The pulse oximeter is a small clip-like device. It attaches to a body part, most commonly to a finger. Medical professionals often use them in critical care settings like emergency rooms or hospitals. Some doctors, such as pulmonologists, may use them in office settings. You can even use one at home. The purpose of pulse oximetry is to see if your blood is well oxygenated. The Max30100 pulse oximeter and heart rate sensor is an I2C based low-power plug-and-play biometric sensor. It can be used by students, hobbyists, engineers, manufacturers, and game and mobile developers who want to incorporate live heart rate data into their projects. The module uses a simple I2C interface for communication with the microcontroller. However, we do not recommend you to use this device for medical purposes to evaluate patients' conditions. This is only for educational and learning purposes. The device has two LED, one emitting red light, another emitting infrared light. The wavelengths of these LED are 660 nanometer and 880 nanometer, respectively. For pulse rate, only infrared light is needed. Both red light and infrared light are used to measure oxygen levels in the blood. When the heart pumps blood, there is an increase in oxygenated blood as a result of having more blood. As the heart relaxes, the volume of oxygenated blood also decreases. By knowing the time between the increase and decrease of oxygenated blood, the pulse rate is determined. The Max30100 sensor is capable of measuring blood oxygen and heart rate. We can use any display like a 20x4 LCD display to view the value of SpO2 and BPM. The blood oxygen concentration termed SpO2 is measured in percentage and heartbeat pulse rate is measured in BPM. You can use this sensor with any microcontroller like Arduino, ESP8266 or ESP32 and easily measure the patient's health parameters. This low-cost DIY pulse oximeter sensor can be used in multiple applications. The wiring is fairly easy. Simply connect the V-in pin to Arduino's 3.3V and GND to ground. Connect the SCL pin to the I2C clock pin and the SDA pin to the I2C data pin on your Arduino A5 and A4 respectively. We will use 10k external pull-up resistors on the SCL, SDA. Following are the components that you need for interfacing Max30100 pulse oximeter sensor with Arduino. The components name as follow. The program for interfacing Max30100 pulse oximeter with Arduino Nano is written in C program for Arduino IDE. This code will display the value in serial monitor and 20x4 LCD display. There are several libraries available for the Max30100 sensor. Max30100 library exposes most of the features of this offers simple and easy to use functions to calculate pulse rate and SpO2. You can download this library from within the Arduino IDE library manager. This is where the fun really begins. In this project, we will measure heart rate and blood oxygen level of the person we are monitoring. Let's start at the top of the example. Two libraries Max30100_pulseoximeter.h and wire.h are included. A constant called reporting_period_ms is defined to delay the measurements. Pulseoximeter object is created and a variable called TS last report is created to store the time at which the last beat occurred. At the setup, the POX.begin function call makes sure that we can communicate with the sensor. Begin function returns 1 on success or 0 if it fails. It also configures the Max30100 to begin collecting data. In the main loop, the biometric data is collected from the Max30100 sensor with the update function. It actually pulls data in from sensor FIFO. We then print the biometric data on the serial monitor once every second. For this we use millis instead of delay. Since delay pauses the entire code, we cannot get the updated measurement. Now we WIL upload the code to Arduino Nano and see the value of BPM and SpO2.